In this video, I want to go over two things. The first is good approximation. And secondly, I want to consider what we actually mean by the word probability. So we begin with good approximation. And so earlier we saw in our globe tossing experiment that we said that if there were only 5 possible values for theta, the proportion of the Earth covered by water, we could assign prior probabilities to each one of those values of theta, collect some data, y is equal to 4, n is equal to 10, and arrive at posterior distribution of theta. The downside of this approach is we've only got 5 values of theta. So now what I want to do is create a very fine grid of theta values that go all the way from 0 to 1.0. And then I want to assign prior probabilities to each one of those values of theta. Nice probabilities that sum to 1.0, collect the data, and then repeat the process. So here's some code that's going to help me do that. The first thing I'm going to want is my fine grid of theta values, length of 200, produced by the sequence function with beginning and end points for this vector being 0 and 1 respectively. Then I'm going to obtain the probability density associated with each one of these values of theta by using some R code. It's going to specify a beta distribution with parameter theta, with values theta, and parameters, and we'll go over this more next week. The beta distribution is going to have parameters A and B of 5.5 and 3.0. So this code here will give me 200 values of the probability density associated with theta based on a beta distribution. Then I got to do 2 additional things. First, I combine these 2 vectors, combine theta and theta probability density. I combine those with the cbind function. And secondly, I start off with the probability density associated with these values of theta. But in this table, if I'm going to use Excel, I don't want probability densities. What I want are the actual probabilities. So to convert from probability densities to probabilities, I'm going to use this code here. In any event, what I'm going to wind up with is a very nice plot of 200 points of probability associated with the theta values that go from 0 all the way to 1 against, once I've got those values of theta, the corresponding probabilities, y is equal to 4, n is equal to 10. I can do the calculations. And so I can see that there's my 200 points for my prior. The data consisted of 40% of my tosses were waters. So we're seeing a shift from the prior to the posterior in that direction. A couple things that are worth noting is that when it comes to grid approximation, it's great for learning. It's not going to be used in practice. And in practice, what we're ultimately going to be using is Markov chain Monte Carlo in order to do our Bayesian analysis. The second thing is that even though what we have here, by using this beta function, we can get a really nice looking curve, but the downside is that if I look at this curve and think about it, it doesn't really reflect what I think about my beliefs about the proportion of the Earth covered with water. So I played around with these A and B parameters and got the best curve that I could, but it's still not entirely satisfactory. So if I look at these values of theta, the proportion of the Earth covered by water, you can see that for values less than 0.5, there's a positive non-zero probability that the proportion of the Earth covered by water is less than 0.5. And in my mind, I'm pretty sure that the probability of the proportion of the Earth covered by water being less than 0.5 is actually zero. There's no chance that there's less than 50% of the Earth covered by water. So that's kind of one of the downsides of using those functions to generate priors. Okay, so that was grid approximation. Now I want to move on to this question of what is probability. And there's a couple of ways to think about probability. One is the long run relative frequency of an event. And the second is belief, or equivalently, we can think of that as uncertainty. And now what I want to do is go over 3 examples that explain that distinction between frequentist and Bayesian perspectives on probability. And we'll begin with the globe-tossing experiment. So in the globe-tossing experiment, 5 possible values for theta. The probability that a randomly selected point on the Earth would be water. And these are the prior beliefs associated with each one of those values of theta. And so when we look at this idea of the probability of theta being equal to 0.75 being equal to 0.50, we can look at it here and see that it captures both notions of probability. So first we have this idea that theta is equal to 0.75. In other words, the probability that a randomly selected point on the Earth would be water. That reflects the frequentist perspective of probability as long-run relative frequency. Why is that? Because what this means is that if we were to repeat the globe-tossing experiment an infinite number of times, the proportion of times that my thumb would land on water would be equal to 0.75. But what the Bayesian does is they consider this whole expression. And what they're saying is that if there's only 5 possible values of the true value of theta, that the probability of the actual value of theta being equal to 0.75 is equal to 0.50. So the probability that theta is equal to 0.75 is equal to 0.50, and that's a statement of our belief or uncertainty about what the true value of theta is. Here's another example. If we look at grid approximation, so this would be the posterior distribution for the proportion of the Earth covered by water. Alternatively, the probability that a randomly selected point on the Earth would be water. And the frequentists would look at this and they'd say, well, this is nonsense because we know what the portion of the Earth covered by water is. It's 0.71. What the frequentist would argue is that it's nonsense to have a probability distribution for something that in fact is a fixed value. The portion of the Earth covered by water is not a random variable. It's a fixed value. What the Bayesian would say in response is they would be fully admitting to the fact that yes, there is some true value of the proportion of the Earth covered by water, but they don't know what it is. And what this distribution is showing is the belief or uncertainty about what the true proportion of the Earth covered by water is. So again, the frequentist is reflecting the way the world really is. 0.71, the Bayesian reflecting belief about the world. And then, third example, we've got a coin, we flip it. Spinning in the air, lands on a table, we cover it up by our hand. We lift our hand and find out that in fact, it is a head. So, how do the frequentists and the Bayesians, what would they think about the probability of this coin being a head? Well, while a coin is in the air still spinning, they would both agree that there's a 50-50 chance that the coin is ultimately going to be a head. Once the hand is removed and the coin is revealed to be a head, then they're in agreement that the probability of it being ahead is 1.0. The distinction lies when the coin is on the table, covered up by the hand. So the frequentist thinks about the way the world actually is. And what the frequentist would say is that once that coin has landed on the table, everything's settled. The game's over. Either it is a tail with a probability of 0 of being ahead, or it's a head with a probability of 1 of being ahead. Everything changes from here to here. In contrast with the Bayesians, who think about probability as belief, nothing has changed. There's nothing happening between here and here that changes their belief about whether or not that coin is ahead. That change doesn't occur until they remove their hand and reveal that in fact it is ahead. Now, some people might argue that there's an advantage to the frequentist point of view because it reflects the way the world really is, whereas the Bayesian perspective, again, is more focused on belief or uncertainty. But this distinction about what we mean by the definition of probability and probability is a primary distinction between frequentist and Bayesian perspectives. So, just in summary, this video has been about grid approximation and different perspectives about what we mean by the word probability.